Hey everyone, and welcome to Meteorology Matters.
Glad to be back.
So, get this. Scientists are predicting that one of the most active volcanoes on Earth is about to erupt.
Yep, that's right. And it could happen really soon.
Oh, wow. So, where is this volcano exactly?
It's called Axial Seamount, and it's located underwater off the coast of Oregon.
Underwater.
Yeah.
Hmm. So, are we talking like tsunami warnings? Should people be worried?
No need to panic. It's part of the Pacific Ring of Fire, but it's not on the Cascadia subduction zone.
Okay, so no big one worries.
Exactly.
But hold on, an eruption's still an eruption, right? I mean, it's got to be a big deal, especially for, the scientists who study these things.
Oh, absolutely. Axial Seamount is like a superstar in the world of volcanology. It actually erupts pretty frequently, which gives scientists a really unique opportunity to test out their eruption forecasting models.
So it's like a natural laboratory, but without the risk of a city being, buried in ash.
You got it. And the cool thing is, scientists are getting pretty good at predicting these eruptions. They've been monitoring axial seamount for decades.
And what have they found?
Well, they've noticed that the volcano actually inflates as magma builds up beneath it.
Hold on. You're saying the whole volcano inflates?
Yeah.
Like a giant balloon underwater?
It's pretty incredible, right?
So how do they measure that?
They use a bunch of sensors on the seafloor to track the volcano's movements. They found that all the previous eruptions in 1998, 2011, and then again in 2015 all happened when the volcano reached a specific level of inflation.
Wow, so they're basically waiting for the balloon to, hit its limit.
Pretty much.
So what's the current status? Are we close?
Well, based on the inflation rate and the fact that we've seen a recent jump in seismic activity, scientists are predicting the next eruption sometime in 2025. Plus, there have been tons of tiny earthquakes in the area recently, so things are definitely heating up down there.
Okay, now that sounds a bit scary, like I would not want to be swimming over that. But earlier you said axial seamount is relatively safe to study. What makes it so different from the explosive volcanoes we see on land?
Well, the biggest difference is the water pressure. A mile beneath the surface, that pressure is immense, and it prevents the kind of violent explosive eruptions we see with volcanoes like, say, Mount St. Helens.
Okay, so no massive explosions. Got it.
Yep. Instead of a massive blast shooting ash and debris way up into the air, it's a much slower, gentler process.
So it's more like, what, oozing lava?
Exactly. Think slow-moving lava flowing onto the seafloor, creating new crust, and forming these really cool structures we call pillow lavas.
Pillow lavas, what are those?
Imagine these bulbous mounds of lava, some of them reaching hundreds of feet high, scattered all over the ocean floor.
Wow, that's wild. I wish we could actually see it.
I know. Well, we can't exactly throw on some scuba gear and head down there. The tech we have these days is amazing. Axial Seamount is rigged with over 660 miles of undersea cables and more than 140 instruments. They're constantly monitoring everything that happens down there.
Wow, so that's like we have a live feed from an alien planet. What kind of information are they collecting?
It's a treasure trove of data. Real-time readings on everything from seismic activity to changes in temperature to even the gases being released.
And how does that help them predict these eruptions?
Well, finding the patterns hidden within all that data is key to making accurate predictions. And this is where things get really cutting edge.
Okay, tell me more. What's the cutting edge?
Researchers are using AI.
Artificial intelligence
Yeah.
for volcanoes.
Yep. They're using it to sort through all of the massive amounts of data, looking for patterns that humans might miss. It's like having a detective with superpowers working 24/7, cracking the code of axial seamount.
Wow, that's crazy. So they feed all this info to a computer and it learns how to predict these eruptions.
It's pretty wild. And the really cool thing is this tech isn't limited to just underwater volcanoes. What we learn from axial seamount could be applied to eruptions on land, too.
So it's not just, a cool science project. It has real-world implications for people living near volcanoes all over the world.
Exactly. The more we learn about how volcanoes work, the better we can predict eruptions and keep people safe. And axial seamount is a vital part of that.
This is incredibly fascinating. But
Yeah.
let's back up for a second. We've talked about predicting when an eruption will happen, but how accurate are those predictions? I mean, are we talking a specific date and time or more of a general window?
That's a great question, and it brings up the biggest challenge with volcano forecasting. Even with all the high-tech tools we have, there's always some uncertainty.
So even with all the fancy sensors and AI, it's not an exact science.
Unfortunately not. Volcanoes can be unpredictable. There's always a chance they'll do something unexpected. But that's also part of what makes studying them so fascinating.
So every eruption is a learning opportunity, a chance to get better at predicting what might happen next.
That's one way to look at it. It's like a constant back and forth between scientists and nature, each one trying to outsmart the other.
Aha, I love that. And what's next for axial seamount research?
Well, there's a push to develop forecasts based on the physics and chemistry of the magma systems themselves.
So moving beyond just observing patterns to really understanding the fundamental processes behind these eruptions.
Exactly. It's like the difference between reading tea leaves and understanding the entire history of how the tea was grown and brewed. It's a great analogy. And axial seamount, with its, frequent eruptions and relatively predictable behavior, it makes it the perfect testing ground for these new models.
It really is like the ultimate proving ground. Okay, so we've talked about the volcano itself,
Mm-hmm.
but let's not forget this is all happening a mile beneath the surface of the ocean. There's an entire ecosystem down there, right?
Oh, for sure. It's a world most people will never see. Total darkness and intense pressure. But even in these extreme conditions, life finds a way.
I can't even imagine. I'm picturing all those like bizarre deep sea creatures,
Yeah.
giant tube worms and, blind shrimp,
Hmm.
stuff like that. It's like a sci-fi movie down there.
It is pretty amazing. These creatures have evolved to survive in conditions that would be lethal to most life on Earth. They get their energy from the chemicals released by hydrothermal vents powered by the volcano's heat.
That's wild.
Mhm.
It really is an alien world down there, thriving in the darkness and fueled by a volcano. But I imagine an eruption must really shake things up, right?
Yeah, it's a big disruption. You've got huge amounts of heat and chemicals being released, and the lava flows can reshape the seafloor, creating new habitats but destroying others.
So some organisms might benefit, while others, might not fare so well.
Exactly. It's a delicate balance. But it's important to remember that these deep-sea communities have evolved alongside axial seamount for a really long time. They're adapted to its cycles of eruptions and dormancy. Many of them are surprisingly resilient.
Wow, nature is incredible. So they're kind of used to the volcano throwing a tantrum every few years. Makes you wonder how they handle such dramatic changes.
Yeah, it's fascinating.
Yeah.
Right. Well, some species can migrate away from the eruption zone. Others have evolved ways to actually tolerate the heat and chemicals, and some might even thrive in those newly created habitats.
Nature is so resourceful, always finding a way. It's like a reminder that life is incredibly adaptable, even in the face of, what seems like total catastrophe.
It's a testament to the power of evolution, for sure. And it makes these deep-sea communities even more fascinating to study. Scientists are eager to see how they'll respond to this next eruption. It'll teach us about the limits of life, the strategies they use to survive in such harsh conditions.
It's like having a front row seat to evolution in action. I have to admit, I'm a very visual person. When I think of a volcano, I imagine those classic images. Fiery lava fountains and, plumes of ash shooting into the sky. So what does an underwater eruption actually look like?
Well, unfortunately, nobody's going to be watching this eruption with their own eyes. We're talking about a mile underwater, hundreds of miles offshore.
Yeah, that makes sense. So are we relying on sonar or something? How do we even know it's erupting?
We're going high-tech with this one.
Yeah.
Scientists are hoping to use something even cooler, ROVs.
ROVs, as in remotely operated vehicles.
You got it.
So they're sending robots into an erupting volcano.
It's pretty amazing. These ROVs have high-definition cameras and powerful lights. They can capture incredible images of molten lava flowing across the seafloor.
Wow, so we're talking about seeing those glowing rivers of lava all lit up in the darkness of the deep sea.
Exactly. And it's not just about the visuals either. They can collect lava samples and analyze them, which gives us more clues about the volcano's inner workings.
I'm getting chills just thinking about it.
They'll also use hydrophones, which are underwater microphones. That way they can record all the sounds of the eruption.
So like the hissing of escaping gases and the rumbling in the seafloor.
Exactly. And the explosive pops as that hot lava hits the cold seawater.
That's incredible. It's a visual and auditory feast for scientists. And thanks to all those undersea cables, scientists from around the world can basically follow along in real time as all this data streams in from the depths.
It's a global effort to understand one of our planet's most active volcanoes.
This is truly mind-blowing stuff. When you think about all the technology and the expertise involved, it really makes you appreciate the dedication of the scientists who study these things. They're not just, stuck in a lab analyzing data. They're out there pushing the limits of what's possible.
It's true. Volcanology is a field that combines scientific rigor with, a spirit of adventure. It takes a special kind of person to want to head out into the middle of the ocean and wait for a volcano to erupt.
I have so much respect for them. They're like explorers from a Jules Verne novel, venturing into the unknown depths of our planet. And speaking of exploration, I've always been fascinated by the connection between volcanoes and, the formation of our Earth. These things have been shaping our planet for billions of years.
Absolutely. Volcanoes are a fundamental part of Earth's story. They're responsible for creating new land, releasing the gases that formed our atmosphere, and even playing a role in the very evolution of life itself.
That's incredible. It really puts things into perspective. It's humbling to think about the scale of these processes, how something as seemingly destructive as a volcano can also be so creative and, shape the world we live in.
It's all about perspective, right? We tend to focus on the immediate dangers of volcanoes, but they play a vital role in the grand scheme of things. They're a powerful reminder that our planet is dynamic, constantly changing and evolving.
It makes you realize that we're just a small part of something much bigger, something that's been unfolding for billions of years. Okay, so we've talked a lot about the scientific aspects of axial seamount, but I'm curious about the human element. What motivates the people who dedicate their lives to studying this volcano?
I think it's a mix of things. There's the thrill of discovery, the satisfaction of solving these scientific puzzles, and the desire to contribute to our understanding of the world. But there's also something deeper, a sense of awe and respect for the sheer power of nature.
I can definitely see that. It's like they're trying to decipher the language of our Earth, understand its whispers and its roars. And in the case of axial seamount, it seems like they're doing a pretty good job.
They are, and the more they learn, the more questions they uncover. It's a never-ending quest for knowledge, driven by curiosity and passion.
It's inspiring to think about all the work that goes into this, all the hours of observation and analysis, and the collaboration between scientists. It really highlights the power of human ingenuity, our desire to make sense of the world around us.
It really does. It's a reminder that even in the face of seemingly impossible challenges, we humans have this amazing capacity for innovation and discovery. That's a message worth sharing, wouldn't you say?
100%. It's a message of hope and resilience. A reminder that even though we face serious challenges, we also have the potential to overcome them, through knowledge, collaboration, and by pushing the boundaries of what we think is possible.
Well said. Axial Seamount, with all its mysteries and surprises, is a perfect example of that. It's a story that's still being written. I can't wait to see what the next chapter holds.
Me too.
Uh-huh.
But before we get too caught up in the future, let's come back to the present for a minute. We've talked about the benefits of studying axial seamount, but I think we should acknowledge the risks too. I mean, this is an active volcano after all. What precautions are they taking to ensure the safety of the researchers, the equipment, all that?
That's an excellent point. It's something scientists take very seriously. The research vessels, the ROVs, they're all equipped with top-notch safety features, and the teams go through intense training to prepare for anything.
So it's not just a matter of, throwing caution to the wind and hoping for the best.
Not at all. There are very strict protocols to minimize the risks. Like, they operate the ROVs remotely, so nobody needs to be anywhere near the eruption. And the research vessels are always keeping a close eye on weather and sea conditions. They're ready to evacuate if things get dicey.
It sounds like they're well prepared. But let's be real. With nature, there's always an element of unpredictability.
Yeah.
Right? Volcanoes have a way of surprising us even when we think we've got them figured out.
You're absolutely right. No matter how much we learn, there will always be some risk. But I think that's part of what makes studying volcanoes so compelling. It's a constant reminder of the power and mystery of the natural world.
It's a healthy dose of humility for us humans, reminding us we're not always in control. But even with that uncertainty, there's a certain beauty to it, wouldn't you say?
Absolutely. It's that sense of awe and wonder that drives us to explore, to learn, and to keep pushing the boundaries of what we know. Axial Seamount, with its incredible eruptions and these hidden ecosystems, is a perfect example of why we keep on exploring.
So well said. Okay, so we've explored the science, the risks, and the wonder of axial seamount. But now I want to talk about something that's been on my mind. We've talked about the potential impact on the DP ecosystem, but what about the ocean as a whole? Could an eruption of this magnitude have any noticeable effects on, like, ocean currents or even global climate?
That's a great question, and honestly, it's one that scientists are still trying to wrap their heads around. Volcanic eruptions, both on land and underwater, they release a lot of gases and particles into the atmosphere and the ocean. And those emissions can have all sorts of effects. Some are short term, some are long term.
So the impacts could go way beyond just the area right around the volcano.
Right. For example, big eruptions, they can shoot sulfur dioxide way up high into the stratosphere. And up there, it can form these things called sulfate aerosols that reflect sunlight away from the Earth.
So that's like a natural sunblock.
Kinda. And that can actually have a cooling effect on the planet, potentially offsetting some of that warming we're seeing from greenhouse gases.
So volcanoes can act as a sort of like a natural thermostat, helping to keep Earth's temperature in check.
In a way, yeah. But it's complicated. The effects can vary depending on, the size of the eruption, where it happened, and what the atmosphere is like at the time. Scientists are still studying all those connections, trying to figure out exactly how volcanoes influence our climate.
It sounds like there's still a lot we don't know, but it's pretty amazing to think about those connections, how something happening deep down on the ocean floor could have these far-reaching global impacts.
It really shows how interconnected everything on our planet is, right? The atmosphere, the oceans, the Earth's interior, it's all linked together in these intricate ways.
It reminds us that we can't just study things in isolation. We've got to look at the bigger picture to see how, a change in one part of the system affects everything else.
Exactly. And that's one of the biggest challenges and the rewards of studying Earth science. It forces us to think critically, to connect the dots and to appreciate how complex our planet truly is.
Well, speaking of complexity, one thing that's always fascinated me about Axial Seamount is its location within the Pacific Ring of Fire. For anyone who's not familiar with that term, can you give us a quick rundown of what the Ring of Fire is and why it's so geologically active?
Sure. The Ring of Fire is this horseshoe-shaped zone that basically circles the entire Pacific Ocean. It's known for intense volcanic and earthquake activity. And all that activity is driven by plate tectonics, which is the movement of those massive plates that make up the Earth's crust. In the Ring of Fire, those plates are colliding, sliding past each other, and sometimes even diving beneath each other, which we call subduction. All that pushing and shoving generates a ton of heat and pressure, and that leads to the formation of volcanoes and triggers those earthquakes.
So Axial Seamount is just one piece of this giant puzzle, a puzzle that spans the whole Pacific Ocean.
That's right. And it's a puzzle that scientists are still putting together. The Ring of Fire is a very dynamic region, constantly changing, and there's still so much to learn about its geology, its history, and all those forces that shape it.
It's a constant reminder that we live on a planet that's constantly in motion, always changing and evolving. And volcanoes like Axial Seamount are a dramatic testament to that, dynamism.
Couldn't have said it better myself. And they give us this incredible window into the inner workings of our planet. It's a chance to study the processes that shaped our world and that still influence our lives today.
Now, I have to ask, is there any concern that an eruption at Axial Seamount could trigger other eruptions in the region? Could it set off a chain reaction along the Ring of Fire?
That's a question that's been on scientists' minds for decades. It's true that eruptions can sometimes influence nearby volcanoes, but we still don't completely understand how those interactions work.
So it's not as straightforward as, like, one eruption setting off a domino effect.
It's way more complex than that. It depends on the distance between the volcanoes, the types of magma involved, and the stresses in the Earth's crust. It's like a delicate balancing act.
So while an eruption at Axial Seamount could have some impact on nearby volcanoes, scientists aren't super concerned about a chain reaction.
Exactly. Most scientists agree that the chance of axial triggering a cascade of eruptions is pretty low. But of course, they're monitoring the entire Ring of Fire, keeping an eye out for anything unusual that might signal a potential threat.
Makes sense. So they're ready to jump into action if they see any warning signs. Okay, let's shift gears a bit. We've talked about how incredible nature is, but now I want to talk about us, humans. How much are our activities affecting volcanoes?
That's a really important question. We're living in a time of incredible technological advancements, and we're consuming resources at an unprecedented rate. And there's growing evidence that some of those activities, especially things that change the balance of fluids within the Earth's crust, can affect both volcanic and seismic activity.
Can you give some examples?
Sure. One is the extraction of groundwater and hydrocarbons. That can reduce pressure in the Earth's crust, which can sometimes trigger earthquakes or even eruptions. And then there's the injection of fluids back into the ground, like we see with wastewater disposal or hydraulic fracturing. That can increase pressure and induce seismic activity.
So it's not just a one-way street, us observing nature. Our actions can actually influence how the Earth behaves.
Exactly. It's a bit sobering to think about it. Our activities can have these ripple effects, and we might not always fully understand what those are or what the consequences might be.
It definitely highlights the importance of being responsible with our resources and really thinking about the potential impacts of our actions. Okay, so we've talked about the risks and challenges, but it's important to remember that volcanoes aren't all bad. In fact, they provide lots of benefits. Can you tell us about some of the ways they contribute to life on Earth?
Definitely. Volcanoes are often seen as destructive, but they're also incredibly creative and beneficial. For instance, they've played a huge role in the formation of the continents and oceans. They release gases and particles that, over millions of years, help to create the air we breathe. And volcanic soils are incredibly fertile. They're packed with nutrients that support agriculture and all sorts of amazing ecosystems.
So volcanoes aren't just fire and brimstone. They're essential for life itself.
100%. They're fundamental to Earth's systems. They shape the planet into the home we know and love.
It reminds me that even when we see destructive forces, there's always a creative element too. And it's that balance that makes our planet so dynamic, so fascinating.
Exactly. And it's a balance we need to respect and understand if we want to ensure a sustainable future, both for ourselves and for future generations.
So Axial Seamount. It's been fascinating to explore its secrets and what it can teach us about our planet. But as we wrap up today, what's one thing you hope our listeners take away from this episode? What's the big picture message here?
For me, it's a message of interconnectedness and humility. Axial Seamount isn't just some lone volcano down in the ocean. It's part of this vast, complex web that includes plate tectonics, ocean currents, ecosystems, and even the Earth's climate. Understanding these connections is key to addressing the challenges we face as a species, things like climate change and natural disasters.
So studying volcanoes isn't just about scientific curiosity. It's about understanding our place on Earth and how we can, impact those systems.
Absolutely, and it's a reminder that we need to treat our planet with respect.
Well said. That's a message we can all take to heart. Well, everyone, that's all the time we have for this episode of Meteorology Matters. Big thanks to our expert for joining us and sharing their insights into the amazing world of axial seamount.
My pleasure. And don't forget, this is just the beginning of the story. Axial Seamount is out there, rumbling beneath the waves. Who knows what new secrets it'll reveal in the years to come. Stay curious, everyone.
And if you want to learn more, make sure to follow meteorologist Rob Jones on social media. You can find him on Instagram at Meteorologist, on TikTok at TV Meteorologist, and on YouTube at Rob Jones Hurricane. You can also find the Meteorology Matters podcast playlist there for more deep dives into weather, volcanoes, and everything Earth science. We'll be back soon with more fascinating stories about our incredible planet. Until then, stay curious.